An identity matrix is one of the most important matrices we will look at in the topic of matrices. What does identity mean? In mathematics, it means getting the same answer as the original number. Let me give you a couple of examples. What multiplied by 3 will give us 3? Yes, what multiplied by this number gives us the same number. It's 1. And 3 multiplied by what will give us 3? 1 again. Multiplying any number with 1 gives us that same number. The number 1 is called the multiplicative identity. No matter what number it is multiplied with, it will give us the same number. So you can probably guess what an identity matrix is. No matter which matrix it is multiplied with, it will give us the same matrix. A 2 by 2 identity matrix looks like this, and a 3 by 3 identity matrix looks like this. How can we define it? It is a square matrix which has all the elements in the leading diagonal as 1 and the rest of the elements as 0. Leading diagonal elements equal 1 and others are 0. Let's say we have a square matrix A. Matrix A multiplied by I will give us matrix A. Some matrix multiplied by I will give us that same matrix. Wait, we also know that matrices are non-commutative. A times I gives us A, but does I times A also give us A? Yes, I times A will also give us A. The identity matrix, when multiplied with any matrix, gives us that same matrix back. It is also called the unit matrix. Will this always work for any square matrix? If the order of the identity matrix is same as this one, then yes, it will always work. Let's look at a matrix on a new page. This is matrix A. We need to check if A multiplied by I gives us A. This is A, and as this is a 2 by 2 matrix, the identity matrix will also be 2 by 2. It will be 1, 0, 0, 1. We need to check if this product of two matrices gives us matrix A back. Is this product compatible? The order of both the matrices are 2 by 2. As the second and the third numbers are equal, this product is compatible. And the order of the resulting product will equal the first number by the fourth number. 2 by 2 again. So what will be the 1/1th element of the resulting matrix? First row times the first column. 1 multiplied by 1 plus 0 times 0. It will equal 1. For the 1/2th element, we multiply the first row with the second column. 1 multiplied by 0 plus 0 times 1. It will equal 0. The first two elements are the same as A. Let's find the remaining two. The 2/1th element will equal the second row multiplied by the first column. Minus 2 multiplied by 1 plus 3 times 0. We get minus 2. And the last element will be the product of the second row and the second column. Minus 2 multiplied by 0 plus 3 times 1. We get 3. That completes our matrix. And we see that the product AI gives us a matrix which is equal to matrix A. Matrix A multiplied by the identity matrix gave the matrix A back. Now we also need to check if I times A gives us matrix A. This is the identity matrix and this is matrix A. Pause the video and try to find the product. Both matrices are 2 by 2 matrices and hence this product is compatible. And the order of the resulting matrix will be 2 by 2. There will be 4 elements in the resulting matrix. The 1/1th element will be equal to the first row times the first column. 1 multiplied by 1 plus 0 times minus 2. It will equal 1. To find the 1/2th element, we multiply the first row with the second column. 1 multiplied by 0 plus 0 times 3. It will equal 0. The 2 1th element will equal the second row multiplied by the first column. 0 multiplied by 1 plus 1 times minus 2. We get minus 2 here. And the last element will be the product of the second row and the second column. 0 multiplied by 0 plus 1 times 3. We get 3. That completes our matrix, and we see that it is equal to matrix A as well. The orders of both matrices are the same and the corresponding elements are also equal. If I is the identity matrix, then both A times I and I times A will give us matrix A.